Hi everybody, welcome to section 7.2, more on inverse trig functions, but today we might get into secant, cosecant, tangent, cotangent also. Okay, so let's find some exact values. So you can put your calculators away, and we're kind of doing like a double trig function here. So I'm going to start by drawing a picture, because that always helps me see what's going on. So let's do the inside function first. Inverse tan of 1/2 means at what angle is tangent 1/2? And I know that inverse tan's domain is from negative to positive pi over 2. And since it's positive, I know that I'm going to draw my triangle in the first quadrant. Okay, so if tan is O over A, I know this is 1 and this is 2. And then Pythagorean theorem gets me root 5. Okay, so this inverse tangent part is giving you the angle theta. But then let's jump to the outer function. They want sine of that angle theta. And it doesn't even matter what theta is. In the end result, we just want the sine ratio of this angle. So that's O over H. So the final answer is 1 over root 5, but if you rationalize it, it's root 5 over 5. All right, so the inner function is telling you what the angle is, and then the outer function wants the actual ratio without even finding the angle. Okay, let's do a couple more. So number 2 here, let's figure out what quadrant we want the inverse sine inner function to be in. Well, sine's inverse exists between plus or minus pi over 2 also. So since it's a negative ratio, we're going to draw our triangle in the fourth quadrant. And since sine is O over H, we know that opposite is negative 1 and hypotenuse is 3. And then Pythagorean theorem will give you square root of 8, which is 2 root 2. Okay, so again, this is telling us what angle does this all happen. But then the final answer, we go to the outside, and it doesn't matter what theta is, they want what's the cosine ratio at theta. Well, cosine is A over H, so final answer is 2 root 2 over 3. All right, and then here's one more. We'll do it. And if you guys ever don't need one of these, feel free to pause it and try it and just check it. So one more, since this video is kind of short anyways. Now this one, where is cosine's inverse restriction? Well, if you remember cosine's inverse, we restricted from 0 to pi. Now, since it's negative, we know it's going to be in quadrant 2, our triangle. Okay, cosine is A over H, so we know this is negative 1 and this is 3. And then by Pythagorean theorem, that gives us the missing side as root 8 or 2 root 2 again. Okay, but again, that's just giving us theta. Final answer, we want to go to the outside. We want the tan ratio at theta. Well, tan is O over A, so that comes to negative 2 root 2. All right, so those aren't too bad. All right, now let's jump into secant, cosecant, cotangent inverse functions. All right, now let you guys kind of study this table here. Something important that you guys need to note for today. Secant's inverse restriction is 0 to pi. From 7.1, that is just like cosine. In here, let me make this in purple too. Just so you know, important today, if you have inverse cosecant, its restriction is negative to positive pi over 2, just like from 7.1 sine or tan. Those are the same. And then inverse cotangents range restriction is 0 to pi, again, just like cosine. Okay, that's going to be kind of important later on today. Okay, but before we do that, let's see. So this one's saying inverse cosecant of 2. Find the exact value. All right, which means we won't need a calculator. So what is this saying? This is saying at what angle is cosecant equal to 2? All right, so let's write that out. At what angle is cosecant equal to 2? But isn't cosecant just the reciprocal of sine, right? So couldn't maybe an easier way to do this be the sine of what angle is equal to 1/2? We can just take the reciprocal of both sides. And then this is really easy to calculate on the unit circle. Okay, so at what angle is sine 1/2? Now keep in mind, sine's inverse restriction is between quadrants 1 and 4. Cosecant's inverse restriction is the same. Okay, so we're good to go here. This means that we want our answer to be in quadrant 1 here. So in quadrant 1, when is sine 1/2? And that is at pi over 6. Just knowing your unit circle. Okay, number 2. Okay, well, yeah, there's a letter here, so what do we do with that? I'm just going to draw a triangle like we did for the first few. Okay, now tan's inverse restriction, if you remember from 7.1, is from negative pi over 2 to pi over 2. So since u is positive, we're going to make our triangle in quadrant 1. All right, so we know tan is TOA, so opposite is u, adjacent must be 1. And then by Pythagorean theorem, a squared plus b squared equals c squared, the c, or the hypotenuse, is going to be the square root of u squared plus 1. Okay, and then this inverse function is giving us theta. But let's look to the outside. We want the sine ratio at angle theta. And sine is O over H. So that would be u over square root of u squared plus 1. Okay, that would be your answer. If you rationalize it, it would be u root u squared plus 1 all over u squared plus 1. That would be the rationalized answer. But either one would be fine for this. Okay, let's keep going. Now, the bottom can get a little sneaky, so make sure you guys are still with me here. Some of this is a little tricky. Okay, so now we're on the calculator. Use a calculator to approximate each expression in radians to 2 decimal places. So first of all, make sure your calculator is in radian mode. And whenever it's secant, cosecant, the reciprocal inverses, it's easier to convert them, kind of like we did this one, into a non-reciprocal trig function. So here's the story. Okay. Secant's range, inverse secant's range, is 0 to pi, just like cosine. So let's convert this into a cosine inverse, and then it's going to be really easy to solve. Okay, so this really means secant of what angle is 3? And if we take the reciprocal of both sides, that really means cosine of what angle is 1/3. Now that's not on the unit circle, so we have to use our calculator. All right, so you guys are going to find inverse cos. What angle produces a ratio of 1/3 at cosine? And that 2 decimal places? Yeah, so 1.23. All right, so this is 1.23. That's the angle in radians. All right, letter B. Inverse cosecant has the same range as sine or tangent. so we can pick. I'm going to use sine because that goes with cosecant. So this is saying cosecant of what angle is -4? Well, converting it into sine would be sine of what angle equals -1/4. And again, not on the unit circle, but we can do inverse sine to find the angle in radians. So inverse sine of -1/4. And that gives us, in radians, -0.25. All right, so that one's done. Okay, moving on. You guys are doing great. Inverse cotangent has the same range as cosine. So I know you would be tempted to convert this to tan, but we want to use one that has the same range so we get our answer in the right quadrant. So somehow we're going to have to convert this to cosine since they have the same range. Here's where it gets a little confusing. Okay, so let's just do what we've been doing. This really means when is cotangent 1/2? But what does that mean in terms of cosine? And in order to do that, you might have to draw a little triangle. All right, so if cotangent is, well, that's what? A over O, right? So the reciprocal of TOA. So A over O, 1/2. Pythagorean theorem gets you √5 for the hypotenuse. So what would this be in terms of cosine? A over H, so 1 over √5. And now let's go ahead and do inverse cosine to get our angle. All right, so we have inverse cos of 1 over square root of 5. And that is 1.11. All right, you got to use a trig function that has the same range for its inverse. Okay, so very similarly, last one, letter D, cotangent's inverse, its restriction for the range is the same as cosine. So we kind of need to do the same thing and convert it to cosine first. So this means, when is cotangent -2? All right, so let's draw a little triangle and let's see what's happening here. Now, since cotangent's inverse restriction is from 0 to pi, and it's negative, then we know that it's in this quadrant, right? Okay, so if cotangent is -2, that means adjacent is -2 and opposite is 1. And Pythagorean theorem gives us √5 again. All right, so in terms of cosine, this really means cosine of what angle is A over H, -2 over √5. And then that's really easy to calculate. So inverse cos of -2 over √5. And that gives us, in radians, 2.68 degrees. I'm sorry, radians, not degrees. All right, if you guys have more questions on this, I can address it when we talk about this in class the next day. Okay, thank you for watching Inverse Trig with secant, cosecant, and cotangent.